Welcome to LIV Academy once again. This is a continuation of gamma functions, solution to gamma function problems. We are to evaluate um, integral of 0 to infinity x to the power 4 e to the power negative x dx. And like I always said, anytime you see integral problem and the limit is from 0 to infinity, try pushing your mind to gamma functions. And before we're able to solve this problem, we have to look at the general gamma function, the general gamma function formula. So the general gamma functions formula is of the form gamma n equal integral from 0 to infinity. That is how I write my infinity. N minus 1 e to the power x dx. Like I said earlier, for gamma functions, why we are treating gamma functions is that these functions help us to evaluate integral problems with ease, specifically some integral problems with ease. So the moment the integral problem has a limit from 0 to infinity, try applying gamma functions to see. So it means that before we apply gamma functions to any problem, the idea of gamma function to any problem, we have to look at the limits 0 to infinity, and more specifically exponent of e, it should be minus x, where x is any variable. So x can be any variable, right? Good. But it's so much with this term here. So looking at this problem, is it of the form this? We have s to the power 4 e to the power minus x. E to the power minus x is okay, right? And x to the power 4 is okay, right? But we should know that this r4 has decreased by 1. So in a sense that it means, let's say it could be that the power here was 5, so 5 by 1, 5 minus 1 giving us 4. So 10 minus 1 gives us 9. So anytime you see this power, notice that it is equal to this power. So before we solve this problem, we have to take that one into consideration. So the general gamma problem formula equal integral from 0 to infinity of x to the power n minus 1 e to the power minus x dx, right? So now we want to look for our n. We want to know what our n is. You can just go ahead and know that our n equal 3, but I prefer solving it in order to. So our 4 here should be equal to n minus 1. So n minus 1 equal 4. Then we solve for n. You see that n will be equal to sorry. You see that I said earlier that our n here is equal 3. So it shouldn't be that. This n here, I mean to say 5. So 1 here crossing will become positive, giving us our n to be 5. Like I told you earlier, mostly our n will decrease by 1. So you have to include that one. So now that we know that our n equals 5, and we can say that our gamma n now is 5, right? We know the value for n. Gamma 5 should be equal to n integral from 0 to infinity power 4 e to the power x dx, right? So after we identify our n, the thing is that we can just go ahead and solve for gamma 5. And we know for gamma 5, there are two formulas that we can use any of them to solve. We can put our mind on them when it comes to problems like this. We have the first formula, gamma of n plus 1, giving us n factorial, and gamma of n plus 1, giving us n gamma n. This formula right here is used to solve fractions. When we have fractions problem, we use this to solve fraction. But in case that we have a single number like this, we just use gamma n plus 1 equal n factorial. So we have to find a way of expressing this one into something plus 1. So 4 plus 1 is the same as 5, right? So gamma 4 plus 1 is the same as 5. Then we can just go ahead comparing to this formula, n equal 5, right? So 4 factorial. And 4 factorial is just going to give us 24. So that is how you can solve this problem. I mean, problems of this form. So the main idea is you getting your n. The moment you get your n, then you can just go ahead and start solving it. And to get your n, equate this to n minus 1 and solve for n. So, and you get your n value. So gamma n, you use this formula. I told you, you use this formula when it's not a fraction, and this formula for fractions. So let's look at this problem too. Now, what we should be interested in, that the general gamma problem is of the form 0 to infinity x to the power n minus 1 e to the power negative x. Can we go ahead, or we have something to do? We can go ahead and solve this problem. There's nothing to do again, because looking at the exponent of e is just minus x. The problem will come in when you have something which is not minus x, or minus something, or something which is not of the form this. So we know that n minus 1 should give us 2 on 3, just like that. N minus 1 should give us 2 on 3. Then we solve for our n. So multiplying 2 by 3, we are going to get 3 multiplied by n, 3n, 3 multiplied by minus 1, minus 3, 3 multiplied by 2 on 3. 3 will cancel out, giving us 2. So this 3 should cross to give us 3. So we have 3n equal 2 plus 3, which is 5. So 3n equal 5, right? So dividing through by 3, we should get our n equal 5 on 3. So our n equal 5 on 3. So we just take our gamma 5 on 3. So how do we solve gamma 5 on 3? So this is to say that gamma 5 on 3 is the same as integral of 0 to infinity x to the power 2 on 3 e to the power minus x dx. You see that? So now, from here, we just go ahead and solve for gamma 5 on 3. Forget about it, everything here, and solve for gamma 5 on 3. This is a fraction, right? And it will be better if we use this formula. So gamma n plus 1 equal n gamma n, right? This one is mostly used for fractions. So we have to find a way of making this expression so in a form 1 plus something to give us 5 on 3. So we want to make this we want to express this problem in this form. So n plus something to give us 5 on 3. So what I like doing is that just equate this to this. So you can equate n plus 1. So it means n plus 1, something plus 1 to give me 5 on 3. So 5 on 3. So solving for n, just multiply 2 by 3. So we are going to get 3n. 3 by 1 plus 3 equal 3 by 5 on 3 should give us 5. If you multiply 3 here, to just cancel out. So 3 crossing will give us 2. So 3n equal 2. So let's divide both sides by 3. So our n here equal 2 on 3. So it means that our gamma 5 on 3 is also equal to gamma 2 on 3 plus 1. You see, you solve for n, so 2 on 3 plus 1. If you take your calculator and punch this on, you are going to get 5 on 3, so nothing changed. So gamma 5 on 3 is the same as gamma 2 on 3 plus 1. So now that we have gamma 2 on 3 plus 1, you know that it should be equal to n gamma n. And comparing this to the formula here, what is the value of n? Our n is the fraction right here, so which is 2 on 3. So our n is 2 on 3. So it's just going to be n gamma n, which is 2 on 3 gamma 2 on 3. And we are not done. We have to simplify this problem up to the extent that we get a constant. So we can go ahead. So we have 2 on 3 gamma 2 on 3. So we have to express this term in a form n plus 1, gamma n plus 1, so that we can use this formula. So what plus 1 will give me 2 on 3? You can form an equation again. So n plus 1 should 2 on 3. And solving for your 3, we are going to get 2 by 3, 3n plus 3 equal 2. So 3n equal minus 1. And dividing through by 3, get n equal minus 1 on 3. You see that we are getting negative number. You are supposed to do so that you get, let's say, half or something, half, so that you know that gamma half equal square root of pi. But now that we are getting negative number, it means you can leave your answer in this form. It is accepted. So you do until up to a point that when you try simplifying it further, you will get negative number. Then you can leave it at that point. If you also feel like trying to simplify it, there's no problem with that. But your answer is best to be in this form. So let's try this. Mostly we will compare it to our general gamma function formula. Gamma n equal integral from 0 to infinity x to the power n minus 1 e to the power minus x dx. So comparing this, you could see that the power of x here is half, right? So this term right here, we can rewrite it as x to the power half minus x dx. Half square root of any number is the same as that number raised to the power half. So if it is a variable, it's the same as that variable raised to the power half. So now we are comparing the power of x. That is where our n value is going to come from, so that we can take our gamma n, right? So let's say n minus 1 equal half. So n minus 1 equal half. We are just comparing the powers of x. So this, simplifying this fraction, multiplying 2 by 2, gives us, so 2n equal minus 2 crossing become positive plus 1, 3. So dividing 2 by 2, n equal 3 on 2. So this is to tell us that this is to tell us that our gamma n, which is equal to integral from 0 to infinity x square root of x e to the power minus x dx. Our n right here is 3 on 2. So n right here is 3 on 2. Gamma 3 on 2 equal 0 to infinity square root of x e to the power minus x dx. So it means that if we evaluate this, the value that we are going to get is just for this whole term right here. So this is telling us that we can just go ahead and find gamma 3 on 2. And gamma 3 on 2, we have to find a way of expressing it in a form. Since it is fraction, we are definitely going to use the formula gamma n plus 1 equal n gamma n, right? So we can find a way of simplifying this or into this form. So what I mostly like is equating them. So if you equate something plus 1 to give you 3 on 2 and you don't know that thing and you want to find it. So simplifying this, 2 by n gives us 2 and 2 by 1 gives us 2 equal 3, right? 2 crossing become negative. So we are going to get 1 here. So 2n equal 1. So our n equal half. So this is to tell us that our gamma 3 on 2 is the same as 1 plus half, gamma 1 plus half, because we solve our n to be half, right? 1 on 2. So we can just go ahead and apply this formula. Looking at this, gamma 1 plus half equal what? N right here, comparing this formula to this formula, to this problem, n here is half, right? So we are going to get half gamma half. And gamma half is a constant which is square root of pi. So this is going to be half square root of pi. So simplifying this further, we give our square root of pi all on 2. So like I told you earlier, this is to tell us that at the end of the day, if we were to use our basic knowledge in integration to solve this problem, the answer that we will get is somehow going to be this, but that one is going to be somehow tedious as compared to using gamma functions. It might be tedious. So let's look at our last example under this form of problem, and in the next video we'll deal with cases where the power of e is not minus x. Then we use the substitution from idea to simplify or to solve for those problems, to solve those problems. So looking at this, we know for the general formula, gamma n equal integral from 0 to infinity x to the power n minus 1 e to the power negative x dx. Comparing the powers of x, we are comparing the powers of x to calculate for our n so that we can go ahead and look for gamma n, forgetting everything here. So n minus 1 right here should be equal to minus half, right? And this will give us, multiplying 2 by 2, we are going to get 2n. 2 by minus 1 minus 2 equal, if you multiply here by 2, you are going to get minus 1. So this one crossing become positive, we are going to get 2n equal 1. So n equal half, right? So we are going to get gamma half. And gamma half is a very well-known constant, right? Which is square root of pi. So that's just our answer for this problem. So thank you for watching. See you in the next video.